Hello all. So here we have the T5 January 2017 paper, non-calculator first. I'm going to work my way through that, and in the second half of the video I will do the calculator paper. So question 1 is an estimating question. Estimate the cost of 31 books at 8.85. So 31 books would always be 30, 8.85 is 9, and then we do that as a non-calculator question, so you can write the sum out. 30 times 9, or 9 threes is 27 with a 0, and the answer to get 207. Part B, estimate how many of 18.5 lengths of tape can be cut from 1,500 centimetres. Check first of all they're both centimetres, that's fine. So what we need to do, we need to divide 1,500 by 18.5. Because it's estimating, we make that 20. We put it as a sum, 1,500 divided by 20. Remember, we can stroke out the zeros. 2 goes into 15, 7, remainder 1. 2 goes into 10, 5. So we've got 75. So the answer for that is 75. Question 2 is a biggie, 5 marks. These are the questions we've got to get right if we're looking to get the top marks. Okay, underline what's important. Sean earns £8 per week for 8 hours and during the week, and double time for 4 hours at the weekend. So let's write it down. Quality of written communication. Let's write down what we see. Sean gets £8 for 8 hours. 8 8's 64. That's that bit there. And at the weekend he gets double time. Double time means double the amount of money. So £8 becomes £16, and he does that for 4 hours. So as a sum, write down your 16 times your 4. 4 6 is 24. 4 1s is 4 and 2 is 6, and that gets me 64. And then what I do there is I add the 64 and the 64, this 64 plus this 64, so Sean earns £128. Now, Jane's earning £9 an hour for 6 hours, so that's her 9 sixes is 54. And time and a half, that's that time and a half again. Well, £9 for an hour, and half of 9 is £4.50. So time and a half is the 9 plus the 450, which is 1350. So it's 1350 for 6 hours. So over here, 1350 times 6 as a long multiplication question gives me £81. So Jane's getting the £54 for this here, the 81 for the time and a half, added up correctly to give you 135. So Jane's getting 135, Sean's getting 128. So the question says, who earns more and by how much? Well, Jane earns more by £7. Now, boys and girls, not that difficult, but a lot of arithmetic needed there, multiplication, adding, a lot of writing down information so the examiner can see. Please take your time and get all those 5 marks. Here we have our question about probability. We've got coins, and this again, just to reiterate, the only time we use these words in probability is if they give it to us. Other than that, it's always fractions and decimals. So describe the chance of the coin being circular. Well, there's 5 coins, 3 of them are circular, so that's 3/5. It's more than half, so it's likely. It's not very likely because 2 of them aren't circles, so it would be likely. Have a value less than £1. Well, they're all less than £1, so that's certain. And weighing more than 1 kilogram. Well, 1 kilogram is 2.2 pounds, which if you think about it, it's like a bag of sugar. So none of these coins weigh like a bag of sugar, so that would be impossible. Okay, question 4 is a question about lines of symmetry. We've got 4 shapes here. This shape here is a parallelogram. We've got a triangle, a hexagon, and a circle. Now, again, they're just talking about lines of symmetry, but I've taken the opportunity just to write in lines and rotation. So a parallelogram has 0 lines and rotates twice. This triangle has 1 line of symmetry down the middle but doesn't rotate at all. This hexagon has 6 lines and rotates 6, and of course a circle has an infinite amount of lines of symmetry and an infinite amount of rotations. Okay, so in this question here, the parallelogram has no lines of symmetry, the triangle has 1, the hexagon has 6, and the circle has more than a million, infinity. Remember, a square has 4 lines and 4 rotations. A rectangle and a rhombus, the 2 R's, have 2 lines and 2 rotations. A parallelogram has 0 lines and 2 rotations. An equilateral triangle has 3 lines and 3 rotations. And then our normal shapes, like for example our hexagon has 6 and 6, our pentagon has 5 and 5, octagon 8 and 8, and so on. Just remember these here are the lines of symmetry, these here are the rotations of symmetry. Okay, the next question is a standard question about units between imperial and metric. We're just asking you what imperial unit would you use. Um, a metric unit, if we're going to fill the car, would be litres, and imperial would be gallons. Metric unit run in 20 seconds would be metres, imperials would be yard or feet. And then we have the weight of a biscuit, and the weight of a biscuit would be ounces. Now, it wouldn't be pounds. Remember, pounds, if you think about babies are weighed in pounds and ounces. So the weight of a biscuit is much smaller than a pound, so it'd be ounces, or if it was metric, it'd be like milligrams or grams. Okay, and just to take this opportunity again, just to go back over some of the information to how to get from, remember these are the imperial measurements, miles to kilometres, divide by 5 times 8, kilometres to miles, divide by 8, multiply by 5, pounds to kilograms, divide by 2.2, kilograms to pounds, multiply by 2.2, pints to litres, divide by 1.75, litres to pints, multiply by 1.75. Just bear those in mind, folks, when you're doing conversions. This question is a tricky enough type of question. Basically, you had to understand there's school concert, there's 23 rows of 9 chairs on each side of a middle aisle. So if you do a bit of a drawing, always remember to do a bit of a drawing. You can see this middle aisle. If you can imagine the middle aisle in our gym, and we've got 23 rows. There's 9 chairs here, and there's gone down 23 rows. And also, the important thing to know, there's 9 chairs here, and they're going down 23 rows. So there's 382 people coming to the concert. How many empty seats is there? Well, clearly you need to work out how many seats this side here. So 23 times 9 gives you 207. And the key thing to note that the 23 times 9 gives you 207. So there's 207 seats this side, 207 seats this side to give you 414 altogether. 382 people coming. So 414 minus the 382 gives you 32 empty seats. That's how you work out the answer to that. I think the key thing to understand is that the middle aisle is the key issue, that there's not just 23 rows of 9, that there's 23 rows of 9 both sides. Again, a bit of a drawing, boys and girls, will always help us work that out. Question 7, first part is a bid mass question. We do our brackets first, which is 15. Then we do our multiplication, 1 times 5 is 5, and then that gives us 15 minus 5, which is 10. Next one, for 2 easy marks, substitution question. 2 times A is 2 12s is 24. Put that minus in separately, bring that minus down, and then 3 times 7 is 21, bring that down. 24 minus 21 equals 3. If, for example, though, let's do a question like this. If A was 7 and B was minus 3, what would 2A minus 3B be? Now, watch for this because you'll have double minuses. This number here will be 14. Carry this minus through, and then this 3 times B would be 3 times minus 3, which would be minus 9. Just be careful. Don't just assume that minus to belong to that minus 9. That's the double minus 9, which gives you 14 plus 9, which would be 23 in that question. Okay, just watch for those signs. Take your time. Carry the sign through and work it out from there. And so we have question 8. Question 8 involves a conversion graph. And it's a wee bit more different here because you've only got 1 point here, which is 50, 165. You've got 0 and you have to find a number, and you've got 100 and you've got to find a number. They're telling you that 1 metre is approximately 3.3 feet. So that is 3.3 times 100, which is 330, which is here. And then obviously 0 times 0 is 0 to give you these 3 points. Remember, this is the line. Metres are going to cross the bottom here. Feet is going up here. Now, the key thing I've always said in all diagrams is to work out, at some stage, we will need to work out what each one of those lines are. So those lines there are going up in tens. You can see that's 100, like that's 150, that's 200, that's 50. So they're going up in tens. And across here, they're going up in twos. You can see that's 50, which is 40, 30, 20, 10. So they're going up in twos. Please write them in. We've got to write them in for later on because it'll make our life easier when we're reading across the graphs. Okay, so for three marks, we fill in this and we fill in this, and that gives us a conversion graph, a conversion line that goes through those points and extend the points on. And so for this part of the question, it says use your graph to answer the following. The men's Olympic hammer throw record was 85 metres. How many feet was that? And part D, the women's Olympic shot put record was 75 feet. How many metres was that? and I got both these answers here from the graph. So if I shorten this down and go back to the graph, so the Olympics men's hammer throw was 85 meters. So you'll note that I have marked 85 meters, went straight up and read across to get 280. And then for the other one, it said the women's shot put record was 75 feet. So it went over here to 75 feet, went across and marked. Again, very important, folks, that we draw our lines in, and also that we mark the lines in that we're doing on the conversion graph. The examiner will want to see that. Alright, so that's the answer for both those questions. Part C, the answer was 280. Plus or minus 5 means that because your drawing won't exactly be the same, they'll allow you to go 5 either way. And then for the other one, they'll allow you to go 1 either way of 22. Okay, question 9, even though it doesn't state it, is actually an algebra question. And basically what's happening is this, that 4 identical rectangular tiles surround the picture as shown in the diagram. And they've said clearly this length here is x plus 6, and this length is x. So what we need to do is we're looking to find a formula for the perimeter P. Well, look, don't get yourself caught up in a whole lot of problems with x's and x plus 6's. Basically what that means is this. You have to find the perimeter. So you have to find the length here, 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 and here. Okay, so I've put in all that. I know that length's x, because it's the same as that. I know this is x plus 6, x plus 6, x plus 6. Please write it all down. That's the x, which is there, plus the x plus 6, which is there, plus the x, which is there, plus the x plus 6, which is there, and so on. And what I've done, I've written them all out here, and I've gathered all the x's. 1, 2, 3, 4, 5, 6, 7, 8. 8x, and then 6 and 6 and 6 and 6 is 24. So the perimeter for that is 8x plus 24. Again, folks, don't get too confused by that. Just follow what they're asking you to do and use the information to get the answer. Now, part B is a much trickier part of the question. They're asking for the area of the picture, which is this part here. The picture part is this part here. Okay, so basically what that means is you have to work out what this length is and this length here. Well, we know this is x, and that's x plus 6, which must mean that this length here has to be 6. That length has to be 6. That length, let me just get the pen. That length there has to be 6, and that length has to be 6 as well. Okay, because this bit here is x, and that's x plus 6, which means this bit here must be 6. So the area of the picture must be 6 sixes, which is 36 centimeters squared. Quite a tricky question, that one there. But again, go back over it. Be very careful. I would expect everybody to get this right here, and then use that information to get this answer here. Okay, next question is clearly a distance, speed, time graph information. Now, again, very vitally important we write in what these are going up, and these are going up in 0.2. So you can see that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of those wee lines is going up 0.2. This line here is 7 o'clock. That's 7:10, 7:20, 7:30. So each one of those must be going up in 1. Because if they're going up in ones, that's 7:01, 7:02, 7:03, 7:04, 7:05. We've got to know that information. If we don't know what they're going up in, we'll not be able to plot the distance, speed, time graph. Okay, so very vitally important we put that information in. This is clearly the baker starting off. Goes somewhere, takes a break, either delivering or whatever's happening, goes somewhere again, takes a break, and then comes back home. Okay, I've put this extra stuff in here. That I've added that in. That's the next part of the question. But clearly that's what's happening. So for part A, it says, how far is the hotel from the bakery? Well, the hotel from the bakery is 4 kilometres. It's from here to there. That's 4 kilometres. The second part of the question says, the second delivery is to a cake shop which is 10 kilometres from the bakery. At what time does the baker reach the cake shop? Now, we have to be very careful. It's either 07:20 or 7:20 AM. They will not accept just 7:20. You must put in AM or PM, whatever it is. Because if I shorten that down, we can see, we can bring the graph back up. We can see that at 7:20, that's where he is, or the baker is, at 10 kilometres away, 7:20. The third part here is the distance, speed, time graph, which is this bit here that I have to put in now myself. I'm going to explain what that is. Okay, so I'll just shorten that down for the minute. Now, this is the key question we've got to get, folks. excuse me, it says the baker spends 5 minutes at the cake shop. So if he spends 5 minutes at the cake shop, you can see that I have, because I know they're going up in minutes, that's him there, so that's 5 across, which is his 5 minutes spent there at the cake shop. Now, he spent 5 minutes at the cake shop and then returns to the bakery at an average speed of 40 kilometers an hour. Use this information to complete the graph. So we know he has spent 5 minutes and then he's travelling back at 40 kilometers an hour. So we need to find what time he arrives back. We know the distance, which is 10 because he's 10 away. We know the speed is 40 kilometers an hour. We need to know the distance. So what we do is we do our distance, speed, time, or our graph. We know the distance is 10. We know the speed is 40. Now, because it's 40 kilometers an hour and we're in minutes at the minute, if we do 10 divided by 40, if we struck out the zeros, that's 1/4. So we have to multiply it by 60. So what that means is 60 divided by 4, which is 15 times 1. So in other words, it's going to take him 15 minutes to travel those 10 kilometers. That makes sense because if you're driving 40 kilometers an hour, you're going to in 15 minutes you're going to do a quarter of that, which is 10 kilometers. Okay, so just to reiterate, 10 is the distance, 40 is the speed, 10 divided by 40 is not 4, it's 1/4, and 1/4 of 60 is 15 minutes. So what that really means is he leaves the cake shop at 7:25 and it takes him 15 minutes. So the baker arrives home at 7:40. So if I just put that down and put the graph back up, this is him here, he's leaving it, and he's taken 15 minutes. So that's from 7:25, that's 7:40, so I join that line straight up. Okay, be very careful, make sure you understand the distance, speed, time information. The key thing is to understand that it's 10 divided by 40, and then you've got to multiply by 60 to give you 15 minutes. So if he's there at 7:20, he spends 5 minutes, which is 7:25. It takes him 15 minutes to get home. He's there at 7:40 a.m. Please always watch for AM. Make sure you include that in the information. Question 11 is a probability question. The difficulty being, of course, that it's non-calculator. So they're saying the probability of a letter posted first class is 0.85. So just to note that if it arrives first class, it's 0.85. So if it didn't arrive first class, it would be 0.15. Now that's of no incidence. That's of no relevance to the question. Just to know that, of course, all probability adds up to 1. The probability that a letter posted is 0.85. Eva posts 200 wedding invites first class. How many invitations would you expect? So basically, with a calculator, it would just be 0.85 times 200, which is this information. But because we don't have a calculator, how are we going to multiply by 200? Well, if we multiply by 100, what happens when you multiply by 100? The decimal moves twice, so it's 85. And then you multiply it by 2. 85 times 2 is 170. So it makes sense. If she's posting 200 first class, you would expect 170 to arrive the next day because the probability is quite high. Okay, question 12 is a substitution question worth 3 marks. We've got to make sure, folks, that we get these questions right. This is clearly questions about putting in minus numbers. I can see it already. We can see that there's going to be a problem here. Okay, so P is 36. Put it in. That means divide. R is 3. And then you've got your brackets. 4. That's that minus there. That minus has nothing to do with this. That minus goes in there. And then you've got your T minus 2. Close the brackets. 4 minus minus 2 is 4 plus 2, which is 6. So you've now got 36 divided by 3 onto 6. That means 3 times 6, which is 18. 36 divided by 18 gives you an answer of 2. Now, boys and girls, I have taken 1, 2, 3, 4 lines to get that answer. Please take your time, lay it out nice and neatly and properly so the examiner can see what you're doing, but be very careful with these 2 numbers here. That's 3 easy marks if we're able to deal with this. Next question is a probability question. A golf shop sells gloves in 3 different sizes: small, medium, large, and 2 colours, black and white. Again, with all probability, we probably need to work out how many's here. So how many gloves does the golf shop have in stock? Well, clearly if you add those up, that gives you 88. Part B. The gloves are either for a right hand or a left hand. the ratio of right to left is 7 to 4. So what they've done here is they've introduced a bit of ratio into probability. How many right gloves are there? Well, the right glove is the 7 part. So we know there's 88. Add these parts. 7 plus 4 is 11. 88 divided by 11 gives you, our box answer of 8. So what we do, we multiply 8 by 7, which is 56, and 8 by 4, which is 32. We're only looking for the right hand gloves. The right hand glove is the first part there. So 8 sevens is 56. Quite a lot of work there for 1 mark, folks, because you've ratio and working that out as well to get how many right hand gloves there are. So the answer for that is 56 right hand gloves. Next one, part C. The gloves are all kept together in a box, and a glove is taken at random. What's the probability it's a large glove? Well, we know there are 88 in total. If we go back up to the table, we see the large gloves are these two here, 15 and 12, which is 27. So therefore the answer for that would be 27 over 88 for 2 marks. Question D, I think, is quite a tricky question, and I've written in here, I think, tricky. You can see that I've written in tricky. Now, the reason why it's tricky is this. It says the glove is replaced in the box, okay? 1 glove is taken at random. It is black, so we're only dealing in black gloves. What's the probability it's medium? We're not dealing with all the gloves, just black. So we have to go up and see the black gloves. The black gloves here are these gloves here. They're all black. 10 and 22 and 15 gives you 47. So there are 47 black gloves. Now out of those 47 black gloves, they're asking which gloves are medium. Now the medium is this here, 22. So the answer will be 22 over 47. 22 is the black medium. 47 is that should be all black. 47 is all the black gloves. So the answer should be 22 over 47. And then the last part of the non-calculator questions is got to do with compass work. Okay, 2 boats are 40 kilometers apart. This is boat X and boat Y. Okay, so we can see that that's boat X and boat Y there. Now, the key part here is the scale. It's saying that the scale is 1 centimetres is 5 kilometres. Well, if 5 kilometres is 1 centimetre, then 25 kilometres is 5 centimetres, and 30 kilometres is 6 centimetres. Now, clearly that is important. For this question, we're going to need a ruler, we're going to need our pencil, and we're going to need our compass. Okay, using a ruler and a compass, show this region on the diagram. Now, here's what happens. Okay, let me just move this up. This is boat X, and we know that boat X is 5 centimetres away. So what happens here? You put your point of the compass there, and you measure 5 centimetres on your ruler, which is there. Okay, put the compass there, measure from there to there, which is 5 centimetres. Open your compass up, and that gives you this arc. You always draw an arc. Okay, see I've drawn that arc there right round. That's a 5 centimetre arc. I've drawn it round so you can see it. Okay, then I go over to boat Y, and I measure from here to here, which is 6 centimetres. And I've marked 6 centimetres here. I've got the compass point there. I've opened it up, and I've drawn this arc round like this here. Okay, generally when we're doing our compass work, either from perpendicular bisectors or questions like this, we're always going to be drawing arcs. So the point of the compass here, the pencil here, moving it round, and you can see here. Now, the part in the middle is clearly the question they're talking about. Use this region on the diagram by show this region on the diagram by shading. If we shade this part in here, that's the bit in between. So just to recap, pencil here, pencil point there, compass point there, pencil here, moving around 5 centimetres. Compass point here, pencil here, moving 6 centimetres. The bit in the middle is the shaded part. And here we have the calculator part of the paper. We just finished the non-calculator paper, and now we have the calculator paper 2, and it again is a 1 hour paper, and it's January 17. I'm going to answer this now. So question 1 is a typical reflection question. Just making sure, of course, that we do what we should always do. Count the points to the line, 2 away. That's 3 away. That's 1, 2, 3, 4, 5 away, which is over here. And this is 1, 2, 3, 4, and over there. And just to join the shape up now, just be careful. It looks like a diamond from the outside, but it's not a regular diamond. Just make sure you join the points properly to get your first 2 marks. Part B is about completing it, the shape, so the X's are lines of symmetry. So it was a tricky enough sort of question. This part here was the only part that I gave you from here. So this part here, the bottom part was easy. So that's 1 away over there. This part here is 1, 2, 3 away, which gets you over here. And this part here is 1, 2 away, which gets you there. And then you just follow the lines round. So that gets you the bottom part here, okay? Now, what that really means is that this part here is now flipped up into here. So what you need is get some tracing paper, trace this part here, and then fold it over, and you'll see it gives you this here. Okay, it's very hard to imagine that otherwise. So this part was the easy part. Get a bit of tracing paper. When I'm writing in me, that's just me, that's the bits I added on. And then from this part, trace this part here, and then fold it over, and you can see it comes on there. Have a good go with that, folks, to make sure we're able to use tracing paper for those sort of questions. Second part is rotational symmetry. Again, don't guess it. Ask for the tracing paper, trace the shape round, and you'll find it'll fit 1, 2, 3, 4. When you trace this shape, when you move it round, it won't fit anywhere at all. And when you trace this shape, you'll realise it'll fit round here and here, which will give you number 2. Okay, don't guess it, use the tracing paper. Question 2 is a similar type of working question as the non-calculator paper, a wee bit of workings to do in it. And they're saying basically for the number of days holidays, it's your standard number, there must be a standard number, plus 2 extra days for every 5 years you work. Now for a builder here, the standard number of days is 18 days, so that 18 is this. And Sammy has worked for 15 years. So we need to work out how many days holidays he has. So it says here, for every 5 years you get 2 days. So he's worked 15 years. So if I just move this over a bit, you can see it's sometimes easier to show you. 15 years, I've split it into 5. So 1, 2, 3, 4, 5 gets him 2 extra days. 1, 2, 3, 4, 5 gets him 2 extra days. 1, 2, 3, 4, 5 gets him 2 extra days. So for his 15 years, he gets 6 extra days. That's basically what this is. Sometimes it's easier to draw it to see it. So he gets his 18 standard days plus his 6 extra days. So his 18 plus his 6 gets him 24. Okay, just go back over that to be clear in your mind, you know what that's about. This one here is a backwards question. We know that Jenny has worked for 20 years and she got 28 days. We just need to know what was her standard number. We need to know what this standard number is here. This one here, we need to know what that is. They're asking for the standard number. So again, the same process. She's worked for 20 years. So 1, 2, 3, 4, 5 gets her 2. Another 5 gets her 2. And then, so you can see those 4 5s, which adds up to her 20 years, gets her 8 extra days. So that's her 8 extra days. She gets 28 days in total. 8 of them is extra. So 8 to take away the 20 gives you her 20. 8 from the 20, it gives her 20 standard days. So just to reiterate, 28 days she got, 8 of those are extra, so she got 20 standard days. Here we have an odd probability question, but again, a wee bit more trickier than just the normal standard one. Seems to be getting a wee bit more trickier. First thing to do, first of all, is count the numbers. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. Now, it's always good to work out how many. So 2 has appeared once, there. 3 has appeared twice. 5 has appeared twice. 6 once, and 7 twice. Always good to write that in. It'll help you later on. Which is more likely when the spinner is spun? A multiple of 3 or a multiple of 7? Well, multiples are times tables. So where's the multiples of 3? Well, the multiples of 3 are there. 3 times 3, 3 times 1, which is 3, and 3 times 2, which is 6. So there are 3 multiples of 3. There's the 2 and there's 1. So there are multiples of 3 are the 3 and the 6, and they appeared 3 times. Multiples of 7, well, the only 7 times tables there is 7, 1, which is 7. It appears twice. So the question says, which is more likely to appear, a multiple of 3 or a multiple of 7? Well, a multiple of 3, because there are 3 multiples of 3. Those 2 and that 1. And there's only 2 multiples of 7 there. So a tricky enough type of question, but write this stuff out. In spinners and things like that, write the information down, because you'll need it, and it's easier to see it if you write down the information. Part B. Again, tricky enough. Put an order from least likely to most likely the chances of getting an odd number, an even number, or a prime number. So, because we've written this out, it makes life a wee bit easier. There's 8 of them. There's 8 numbers in total. An odd number. Well, the odd numbers are here, which is 2, 4, 6. So an odd number is 6 over 8. An even number. There's an even number, which is 1 of them. And there's another one, which is 2. So there's only 2 even numbers, 2 over 8. And a prime number. Well, we know the prime numbers are 2, 3, 5, and 7. So they're all prime apart from that one there, which gives you a probability of 7/8. So based on that, I've written the information. An odd number is 6/8, even number is 2/8, and a prime number is 7/8. So from least likely is even. It's only got 2 out of 8. An odd is next, it's got 6/8, and a prime has got 7/8. Please write this information down at the start of any spinner like that. You'll find that it'll help you later on down in the questions. So the next question is a time question and percentage question. Now, please do not, first of all, put in 4:15 minus 2:30 on a calculator. That's not how we work time. We do not do time on a calculator. A train leaves Acton at 2:30 p.m. and arrives in Braun at 4:15. A planned upgrade will cut the travelling time by 20%. After the upgrade, what time will the 2:30 arrive there? Okay, first things first. How long is 2:30 to 4:15? That's 1 hour 45, which is 105 minutes. Now, how I did that is this. 2:30 to 3 is half an hour. 3 to 4:15 is 1 hour 15. So half an hour and 1 hour 15 is 1 hour 45, which is 105 minutes. I have to take 20% off that because it's been reduced by 20%. 20% is 2/10. So it's 105 divided by 10, multiplied by 2 on my calculator, which gives you 21 minutes. So it used to take 105 minutes. It's now been reduced by 21 minutes. So the new travel time is now 84 minutes. So the travel time is now 84 minutes. It leaves at 2:30. You add on 1 hour 24. So 2:30 and 1 hour is, 2:30 plus the hour is 3:30 plus 24 minutes gets you 3:54. And again, like all things in time, we must write in PM or AM at the end. Of course, it's PM here at the minute. Please just don't write 3:54. Okay, have a good look over that question again, understand the workings that I did there, and try it again. Question 5 is rounding to the nearest 100. Well, that's the 100 there. So that, if you can imagine, take out the 1,000, that's 378. And is that close to 300 or 400? Well, it's 400 and you've got the 1,000. One decimal place, arrow to the 7, box it off, the 6 will increase it. So you've got 1378.8. Question 6 is a question about calculators. Again, underline the important things. Teacher buys 40 calculators at $9.59 each and a number of cheaper ones at $5.75. Clearly we don't know how many cheaper ones at the minute, but the total cost for everything is £487.10p. How many cheaper calculators does she buy? Now, first things first, let's get 1 mark for multiplying these two. So 1 mark multiplying by these two is 383.60. Now be very, very careful. On the calculator, if you put that sum in, it gives you 383.6. Remember, decimals, money, we must put in the second number, so I put in that 0. Make sure that's in or you'll lose your mark. Now, we know that the total cost is $487.10 for everything. We know that the 40 calculators cost that. We don't know how many cheaper calculators the teacher has bought. But if you take away the big total from this, that gives you $103.50. That's the total cost left for the cheaper calculators. We know each one is $5.75, so we put that sum in divided by $5.75 on our calculator, and we realise that gives us 18. So the total number is 18 cheap calculators. That's the answer for that. Question 7a is a fairly straightforward one. 14 pencils, 3 has broken leads. What's the probability it does not have a broken lead? Well, there's 11 that doesn't have a broken lead, so it's not 11. Remember, probability is fractions, so it's 11 over 14. Okay, part B, however, is a much more trickier question because we haven't really come across this before, and I'm going to highlight it now to you. The pencil taken does not have a broken lead and is not replaced. Now, that's important. What does that mean, not replaced? Well, not replaced means there used to be 14. It was taken out, but it's not putting back in. So there's only 13 left now. That's very important. I read it again. The pencil taken, which was taken out, doesn't have a broken lead and is not replaced. Okay, so there's now only 13 left in the box. What is the probability the next pencil taken has a broken lead? Now, we know that there are 3 pencils with broken leads. 3. So 3 has to be the top number. Now, instead of being out of 14, it is now out of 13 because it has not been replaced. Now, that has appeared this last year or two, this type of, not replacing it as opposed to always being replaced. So just watch out for that. If this is not replaced, underline that, not put back in, so only 13 left. Have a good think about that. Here we have a ratio question, but again, what they're doing is they're combining it with another type of mathematical piece of information, So what they're saying is that the quadrilateral has angles 120, which is here, and then angles A, B, and C. We don't know those. But then the ratio 3 to 5 to 4. 3 is A, 5 is B, and 4 is C. They want to know angle B. They want to know what this 5 part is. Now, we need to know 360 in a quadrilateral. We've lost 120, so 240 means that this, and this add up to 240. So write the ratio down, 3 to 5 to 4, which is 12 parts. We do 240, which is what the big number is. 240 divided by 12 is 20, box that. And then we multiply 20 by 3, 20 by 5, and 20 by 4 to give us our missing angles. So for example, we know that this angle A is 60, angle B is 100, and angle C is 80. We just have to work out which question they're asking for. So they're asking for angle B, which is 100. Okay, easy enough question, but again, they're asking like two parts of a maths information. They're asking ratio, and they're also asking, do you know how many degrees in a quadrilateral? Okay, so have a good think about that and practice that again. Question 9, again, they're asking two types of information. They're asking, do you really know what a prime number is? And do you really know what a square number is? Well, it's saying, when you add two different prime numbers, the answer cannot be square. Give an example to show that is wrong. Well, let's write down the prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. Let's write down the square numbers 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. Now, when you add two different prime numbers, the answer can't be square. So, for example, let's add two different. There's 2, which is prime, plus 7, which is 9. So, a prime and a prime gives you a square. Next one. A prime 5 plus. Another example should be 5 plus, that should not be 16, that should be 11. Okay. 5 plus 11 gives you 16. 5 being the prime number, 11 being the prime number, and 16 being the square number. So we have shown two examples that when you add two prime numbers, you can get a square number. Now, there's examples that obviously, for example, if you did, I don't know, like let's say 3 plus 5, that would be 8. So that's an example where you don't get a square number. Okay, but they want a pair of numbers that when you add do give you a square number. So in essence, it's one of these two answers here. Okay, but clearly the question is all about prime and square. Question 10 is asking you to put brackets in to make it correct. Of course, you have a calculator here now, so just by a process of trial and elimination, just start first of all, see, well, the answer of course is it goes there and there, but if you're not too sure, just literally just write the question out and stick brackets in until you find 79 on your calculator. So for example, if you put that in first, then you realise that wouldn't work, so then you would, let me get rid of that, and then you'd stick them there, see if that worked, and then you would get rid of that, and then by a process of elimination you know they have to be there. That's the joys of using the calculator. Okay, and then the second one, now this is the old favourite significant figures. The zeros at the start don't count, so you go to the second number, which is 3, box it off. 3 won't change it, so the answer is 0.0073. Okay, what would this be? I'll just give you a typical type of question. 7, 1, 4 to two significant figures. There, box it. 4 won't change it, so that's 71, and then it has to become 0. They're fairly straightforward questions on significant figures. Easy marks, so keep practicing those. Now this question 11, is a very tricky type of question because what they're doing, they're trying to trip you up here. Let's read it. It says, a bag contains a number of coloured discs. Cara takes a disc at random from the bag and puts it back in. She does this 10 times. Here are the outcomes. You've got red, blue, blue, and again, we've done it before. You've got 2 red, 5 blue, and 3 yellow. Looks like a fairly straightforward probability question. However, one thing is really making it quite awkward, and it's this. We do not know how many are in the bag. It doesn't say there's 10 in the bag. It just says she does it 10 times. So that's where it gets quite tricky, and actually a bit, it's actually a bit fly, because they're trying to trip you up. They're trying to say, do you know? They're trying to say, we want you to think there's 10, but there's not 10, because she does it 10 times. It doesn't mean that there's only 10 in the bag. These are the results of the 10 that she did. So first one's straightforward. There are exactly 2 coloured discs in the bag. Well, no chance, because we can see there's 3, so that's impossible. There are more blue than yellow discs. Now if you look at this first 10 that she did, there are more blue than yellow. So they're hoping that most people are right certain. Now it's not. It may be possible, but we don't know how many are in the bag. For example, that's only 10. She might have had to do another 20, or there might be another 50. We don't know how many's in the bag. So we don't know if there's more blue or yellow. That's just possible. It's not impossible and it's not certain, so it must be possible. And again, the last one. Cara picks an 11th disc from the bag. It is black. It might be black. We don't know, because we only pulled out the first 10. So again, even though black's not here, it could be the 11th one, so it's possible. Very, very tricky one. That's not a normal standard probability one. That's a tricky one, and we have to watch out for those type of questions. Now, question 12 is a question we must get right. Okay, so I'm going to spend a good few minutes explaining this properly so we can all get a handle of it. Okay, it's really about money and salaries and real life problems. Okay, so Heather has an annual salary of £32,000. The first $10,800 is tax free. What that means is that she's getting paid this in a year. She does not pay any tax for that amount of money. So out of £32,000, this money is tax free. You take it off. It is not to be taxed at all. So that's your salary. You always take the tax free bit off, and that leaves you $21,200 that can be taxed. Okay, this is not all taxed. Tax free means you always take that off to get the taxable amount of money. Now, she pays 20% off this here. So whatever this money is, you pay 20%. Now we know 20% is 2/10. Divide by 10, multiply by 2. So 20% of 21,200 gives you 4,240. That's how much tax she pays. Okay, how much of her salary is left after paying her tax? So we can see she started with 32,000. She pays £4,240 in tax. So this is how much money she has left after she pays tax. Okay, I'll do another type of example just so we can get it in our head. Let's say Michael was earning £41,000 a year, and the first 11,000 was tax free. So that means if that's tax free, if you take that off, that means he's paying tax on the 30,000. If he's paying 20% tax, that's 2/10. So 2/10 of 30,000. If you divide by 10, that gives you 3,000 multiplied by 2. So that's 3,000. That's 30,000 divided by 10. I'm just doing this in my head. Multiplied by 2. That gives you £6,000. So that £6,000 is how much he's paying in tax. So he started with a salary of 41,000. He's paying £6,000 in tax. So his money that he's left after he pays tax is the 41 minus the 6, which is 35,000. Okay, please be aware of those type of questions because they've appeared this last year or two, and those are easy questions once we understand what it's about. Question 13 is a proportion question. This is the ingredients we need for chocolate ice cream, and it serves 4 people. Underline that. How much caster sugar is needed for 7 people? Well, we must get back to one person first, so it's divided by 4, which gives you 1 multiplied by 7. So that's the formula we're going to be used to get to 7. If it was to get to 9 people, it would be divided by 4 multiplied by 9. Whatever it is, you divide by that number multiplied by this. So we go along to caster sugar. So it's 120 divided by 4 multiplied by 7. 210 grams is needed for 7 people. Okay, second one is a bit more trickier. Okay, so we'll make it a bit bigger. Liz has 13 eggs and needs to make chocolate ice cream for 17 people. Does she have enough eggs? Well, if we can see that 3 eggs, where's our 3 eggs? Our 3 eggs here makes 4 people. So she's got 13 eggs in total. So I've just taken my time and written 3 eggs gives you 4, another 3 gives you 4, another 3 gives you 4, and another 3. So 12 eggs so far gives you 16 people. Now she's 1 egg left over. So what that really means is you have to divide the 4 by the 3, which gives you 1 and a wee bit people. Okay, so 1 egg gives you just over 1 person. Okay, now you can't get 1.3 people, so clearly it's 1 person. So 13 eggs here makes 17.3 people. Now we can't have 17.3 people, so it's obviously 17 people. So the question says, does she have enough? Yes, she does. 13 eggs makes ice cream for 17 people. Okay, have a think about that there and go back over that question yourself again. Here we have a transformation question, and all they really want to know is describe fully the single transformation that maps one onto another. So clearly this is the line, and what they're asking is, do you know, first of all, it's a reflection? Yes. And what is the name of that line? That line is y equals 5. What's this line called here? X equals 8. Okay, just be careful. Remember, X lines go up and down, Y lines go across. Okay, and there's 4 types of transformations. There's the reflection, which is what that is. You've got the rotation. You've got the enlargement. And the last one, you've got the translation. Okay, and the translation, as we know, is vectors. For example, 2 minus 3. Left, right, up, down. Enlargement means bigger or smaller, and we always start from the centre of enlargement. Remember, we do our table like A, B, and C, and we work like, for example, 2 right and 1 up, and so on and so forth, and you multiply it by the scale factor. Rotation, you need to know how many turns, 90, 180, anti-clockwise, clockwise, and you need to know the point, the centre of rotation, where to put the pencil. Okay, go back over those 4 things. They're anything from 2 to 3 to 4 to 5 marks over the 2 papers. We've got to know all those topics. And then the second part of this question is actually a rotation question. So 90 degrees is 1 turn, clockwise is moving around like this, about the point 0.4. So 0.4 is of course this point here. Remember, 0 is across and 4 up, always across before you go up or down. This point here, for argument's sake, would be minus 1, 0. This point here would be 0, minus 1. Be very careful, always across first. So in relation to this question here, you've got this shape, trace it, put your pencil here and move it round, and you'll find exactly at this point here. Okay, just double check that to make sure you know exactly what you're doing. And then the last question is making the subject. First thing to do, as we always do, is a rake of equal signs, equal, 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 equal. We could bring the plus 10 over, which is here, becomes minus 10. Remember, we underline the x because we're looking to find the x, so we get rid of this 8 here. So it's now y minus 10 divided by 8, which is x. And the fancy way of writing that is y minus 10 divided by 8. But this here is still the same answer as this here, although this here is probably a better way of writing it. Okay, and that, boys and girls, is the T5 January 17 non-calculator and calculator. Please take your time, go back over all the questions. If you're not too sure, check out some of the other videos, and best of luck.